Hello, community. What's going on? My name is Gerardo Lopez, aka Falcon, CNCF Ambassador, Docker Captain, and Google Developer Expert. I am very excited with the topic that we have in this Cloud Native Live. We have a special guest, an amazing topic, but of course, before presenting him, I want to explain a little bit what are the different rules and the good way to communicate each other. In the Kubernetes ecosystem, the promise of agility often comes with a major caveat, an overwhelming flood of vulnerabilities alerts. The feeling of drowning in this sea of notification is a daily challenge for both security and DevOps teams. The reality is that not all threats are created equal, and relying solely on basics, different score is insufficient for a dynamic cloud native environment. Today, our goal is to cut through the noise and focus on what Genius Way puts your cluster at risk by providing a practical framework for information prioritization. So again, remember, if you want to ask questions, please use the comment, pay attention, and we are ready to hear you. And of course, let me present our special guest. He is Nigel Douglas. Nigel is developer advocate and classmate. In other words, he is head of developer relations in CloudSmith. So, Nigel Douglas, welcome to this Cloud Native Session Live. We're excited to learn from you. So, it is your turn. What's going on, Nigel?
No, thank you very much for inviting me. I think this should be a fun session. I'm going to try to do a bit of a presentation at the beginning and then get hands-on and show this in the terminal to make more sense of how you would do this yourself.
Nice. Right now, we're excited. We are ready. If you are ready, let me know. If we need to share the screen, I am here in order to support you. And all people, again, please send messages where you are watching from. If you have questions, write the question. And I'm totally sure that Nigel will be totally able and very happy to give the answer. So, Nigel, we are ready, all of you.
Amazing. Thank you very much. So I'm going to start by jumping in and let's see if that works. And of course, if anyone's having issues seeing what I'm seeing, just let me know. And I'm just going to jump into that presentation. So yeah, today's session, it's on the title of Prioritizing the Unpatched CVEs within the Kubernetes ecosystem. So this was something that just kind of came up in my mind a little while ago about the unique CVEs to the Kubernetes itself, the actual orchestrator. So I know that not everyone's going to be familiar with some of the terminology like CVEs, vulnerabilities, CVSS, EPSS, all these scoring systems of like how you prioritize these vulnerabilities. So I'm going to do an introduction to these vulnerabilities. We'll understand the scoring systems because they will matter in a while as to what you're seeing and why some of them are red, some are blue, some are orange, that those matter. So we're going to try and prioritize the unfixed. Now, what we're using is on the Kubernetes project, you'll see here they've had this feature state since Kubernetes version 1.27. We're currently on version 1.34, so it's been around for about 7 versions now, and we're moving on to 1.35 at the end of the year. So if you go into the Kubernetes documentation, which is fantastic, by the way, you'll see this like curl command where you can just curl against the Kubernetes.io API, and you can just retrieve information about these vulnerabilities. And some of them are fixed, some of them are not. I would like to say nearly all of them are fixed, but I will just show you in a second what all this means. So the first thing I want to do is just clarify about vulnerabilities. So there was this great post I saw recently on LinkedIn, and it was by Michael Lieberman from Kusari, and it was on about how most people are misusing the term security vulnerability. So a perfect example is if someone said, I don't know, you've incorrectly configured your authentication. They say, oh, this is a vulnerability you've left open to our environment. That's not what we're talking about when we talk about vulnerabilities. We're talking about essentially breaks in code. So when an application is designed in a way that if someone were to do a certain action, they could bypass it, perform code execution against it in ways that it's not intended for. So that would be a vulnerability. These vulnerabilities are disclosed under unique IDs. So these CVE IDs, we'll talk about that in a while. And of course, we put a scoring system as a way to understand what is the impact of this vulnerability, like describe what could happen with this vulnerability if compromised. So the CVE itself is the common vulnerability exposure. It's the ID we're talking about. That's the unique identifier for the vulnerability. Then you see things like severities. They're like low, medium, high, critical. And then you have CVSS, which is the scoring system that's been around for a long time. But it's like, how much should we be concerned on a scale of 0 to 10 by this CVE? And the score is basically trying to look at like the impact of this vulnerability, but also the exploitability of it. This is later accompanied by another score called EPSS, which is essentially just the dedicated exploitability score. We'll talk about why these two systems work or matter in a while relative to your Kubernetes vulnerabilities. So when we're talking about that API that Kubernetes provided, you can run these 3 very simple commands. Again, there's probably more sophisticated use cases for this, this curl against the API. But the first one, I'm basically doing a JQ to query for items where the status was set fixed. Those are all the CVEs that should be fixed. There should be fixed versions on those, and something you could do to patch and resolve that issue. Unfixed vulnerabilities are the ones where we say, look, we found this vulnerability, and unfortunately, it's so new. We found this thing. We don't really have a solution for it right now, so we can't tell you, oh, upgrade to this version. It's still an open thing. And then there's this other area of unknown vulnerabilities. I'm not entirely sure what this is all about. Maybe it's a case where we haven't addressed a proper status. We haven't assigned a proper status on the vulnerability. Or it could be a case of we just don't know if this thing's been addressed or not. Again, I'm not entirely sure how unknown came to be, but not many vulnerabilities will fall into this group. But you can certainly run that query to find a CV that would be marked as status unknown. So the first one that I want to look at, and I thought was really interesting, is I ran that command at the bottom where you say, curl the API, but I'm querying for select ID. So remember we talked about the CVE IDs? Those are the unique identifiers for that specific vulnerability. So in this case, this was a 2020, so that means it's been around for 5 years, it was disclosed in the year 2020, and it's 8561. So that was the 8561 example of registered vulnerability in that year. Now, what this is a webhook redirecting Kube API server. So by checking for unfixed, what we've found is that there's a CVE. It's been around for like, 5 years now. And it's saying here there's no fix for this issue. Now, when you curl that API, you'll get all that supporting information, not just that a vulnerability exists. It'll tell you what is the compromised component. So we know it's related to this webhook redirecting Kubernetes API server. But you want to know what is the compromised configuration. So in this case, it's to do with mutating webhook config or the validate webhook config. So in these scenarios, yeah, requests are able to redirect from the Kubernetes API server to somewhere else. But how easy is it to compromise thing? So what I'm saying is initially we say, well, that's really bad because, well, everyone's got a Kube API server. That's what allows the communications within our Kubernetes cluster. But if that were to be compromised, well, they could, exfiltrate data or whatever. They could talk to somewhere external. And that's, of course, bad. We don't want someone being able to profile information from our environment. So in each of the cases of these CVEs, they don't just say, well, is there a fix? A fix means I can upgrade, say, Kube API server or my Kubernetes cluster to a version that will address it. And that's the fix. There are temporary patches you can do, for instance, changing file configurations or paths so that it becomes somewhat arbitrary for an attacker to figure out how to actually compromise it. But in some cases, you can do stopgap actions to stop someone from actually compromising it. But then there's mitigation. That's what I mean by mitigation. So in the case of if there's no fix, if there's not a version we can upgrade to, well, then what's the mitigation? What's the thing that we can do? So it says here, well, although there's no fix, it can be mitigated, can be addressed. In this case, if you were to change a value to less than 10, for instance, in this profiling flag. And by doing something like that, well, you're stopping the case where they can just profile all this log value output, so they wouldn't be able to interact with that. So you'll see in each of these cases of CVEs, there'll be different mitigation steps in the case of where there's no fix available. Now, that API that we talked about a while ago, where you just curl that same request, it looks something like this. So you can see where I ran the command and the output said, well, we're interacting with Kubernetes IO. We can see there's a link for the Google groups. So that's going to be the community conversation or announcement on that vulnerability. It's linked to the GitHub project itself, where you have the issue. When a vulnerability is disclosed, of course, you should have an issue. It's pretty much all this information here is taken from the issue. So in it, we see, well, what's the status? In this case, it's an open vulnerability. So it is not fixed. We can see what the ID is, which is the ID we filtered for. When a CVE is created, there should be a record in CVE.org, which is the unique record associated with, which you can, of course, check it in that external source, which is in CVE.org. And the content text, that basically tells you everything I just showed you there a second ago, which is, what exactly is happening, how it can be compromised, what's the score, and what can you do to actually take action. And even things like who reported this. This was reported as part of a security triage, or someone was doing a bug bounty or whatever it is, or a security researcher just discovered this thing. So again, all that information should show up in that content URL. Now, when I talked a while ago about CVE severity, not score, you'll see them being low, medium, high, critical. So in this case, it was a medium CVE severity. So it's something we should be concerned with, but it's not the most concerning thing in the world. Then there's going to be ones that are low severity. And why that often happens is, in the case of this example as well, it says, well, there's no fix at this time. And I double checked this GitHub issue recently, and again, it's still showing that there's no fix for that. So the fixed version doesn't exist. However, there's still mitigation steps. So it says if your issue affects a certain cluster control plane, you can use things like DNS mask, or you can use min cache TTL or neg TTL parameters, basically configure in a way so that they can't bypass the Kube API server. This I can never say it. It's the time of, the talk to a type attack. But my point being here is like the attacker in this case, they would be authorized in order to access private networks. But the reality is it's a lot harder for someone to actually achieve this. And therefore, the severity of this is much lower. Again, things like if there's no fixed version, then it's just a case of like, how hard, how trivial is it for someone to actually perform this attack? Now, where this one's a bit weird is I think it's supposed to be flagged as open. And this is me opening this up as a conversation point. Like, is someone else using this API to actually look for open vulnerabilities at the moment in time? Because in the case of this one that I said has no fix available, it's showing up as unknown. The only rational reason I could think of something showing up as unknown is that it never was correctly assigned the status on the issue. That's my theory. But either way, this is a relatively low severity vulnerability. You can see it was reported also in 2020, and it's 8562. It's actually the next one straight after 8561. And the full information there is provided in that content text. So the next one, again, low example. This one should be reported as fixed. You can see here it's got status fix on it, and that was also 2021, so a year later. Now, in this case, endpoint and endpoint slice permissions allow cross namespace forwarding. Again, mitigation. So there's no patch for this issue. It's currently only mitigated by restricting access. So that is a mitigation step, but it's not a fix. Like we said, it should show up on that API. Fix is when you say there is a version, something you can upgrade to, and you address it. So right now it's saying there's different things you can do. If there's a mitigation step, something you want to look for, which is like, okay, well, I need to go into a config file, which is the system aggregate to edit role. And from here, you remove your write access for admins from specific admin or edit roles. So once you take away those permissions, well, they won't be able to exploit the vulnerability. There's other things like they might look into if there's no mitigation step. Well, what is the monitoring step that you could take? How can I get visibility to see if I am potentially impacted by this thing? So at the very bottom, what I've done is I provided a kubectl get service output for all the namespaces, and then I've created a custom column. So what I'm trying to do is say, from the metadata from all those services and all those namespaces, can you show me, for instance, the name, the namespace, and the selectors that are assigned to it? because if I know that it has the selectors for that endpoint to endpoint slice that are affected by this vulnerability, then at least you can go, okay, I now know I've inventoried that I am associated with this known vulnerability that can be exploited. Then I need to take the mitigation action, which is to modify the existing configurations to take away the admin or edit role. So again, in this case, the user was able to potentially send network traffic to a location via confused deputy attack. And this is basically if we don't have strict controls over those load balancer or the ingress implementation, then those backend IPs become basically exposed. And there's other things you can do as well in regards to egress traffic. It says here, like network policy, what you can do is you can create like zone-based architecture and really restrict what you're doing. But even if the target network policy, as it says here, trust the load balancer or the ingress, then network policy itself actually won't solve the issue. So my point is definitely these issues that are provided with the CVE from the actual Kubernetes IO API provides all this really, really rich supporting information, not just what you would get in like an nvdcve.org view, which would basically tell you, here's a vulnerability, is it fixed or not? Which you want to see like, okay, if it's not fixed, well, what can I do to fix it? Or what can I do to mitigate the vulnerability? So in this case, it says it's fixed. It should have been addressed in a version. Actually, I don't know if it ever said which version it wasn't fixed in, but we could in a while just check the actual issue itself on GitHub, because again, it's all linked here. So issue number 103675. The final one here is again a man-in-the-middle type attack, and it's on Kubernetes C# client certificate validation. This is a clear instance of where you'll say, okay, a fix is available. We know it's vulnerable if you have this Kubernetes C client sharp, whatever, but at least it tells us what are the affected versions, which is everything prior to 17.0.13. So basically upgrading will address the issue. And then what is important when we look at these issues is oftentimes, for whatever reason, they'll say, look, you might be in a case where you can't just simply upgrade that version. You might have other things that are dependent on that C# client and therefore on that specific version. So it'll say here, like, note, if you can't upgrade, so you basically can't address it, then you need to look at things like disabling your custom certificates or your CAs, to address that. So the main thing is like, yeah, if you can upgrade, fine, that addresses the problem. There are mitigation steps as well. So like, again, you could, if you couldn't upgrade at that moment in time, you could move your certificates into a different location than the trusted store. But the problem with that, you wouldn't want to move them into a system trusted store, which works. So the compromise is in kubeconfig. So the point is, if you moved away from kubeconfig, the certificates to somewhere else, if like a trusted store, that would address the initial vulnerability. But what it then creates a system of is that all the processes on your system are now trusting that certificate or signed by that CA, which is something you don't want to do either. So my point is, even though there are sometimes little quick fixes you can do to sort of patch the problem temporarily, you actually create other potential vulnerabilities in the process. Not vulnerabilities, again, not CVEs. They're more like insecure configurations that you've implemented in your environment. So what I've done is I put together this little exploit checker tool, just as context. And again, anyone can use this tool, by the way. It's like completely open sourced. So it's really just a bash script. But you can see at the top, I'm using this exploit check sh tool to query out a given CVE. And the idea is I'm trying to take information from different sources. So like NVD, I want to take information from ExploitDB, Scientia, I think, for the EPSS scores. So those kind of different sources to like understand how I should be concerned about a vulnerability. So when we talked about the different scoring systems, we can see, look, we have a severity coming from NVD, which shows us this CVE associated with that C# client issue is medium severity. It has a 6.8 score out of 10, which is, again, it's in that medium category. And then the EPSS, which is the exploitability score, that's actually really low. It's like 0.02%. So even though we talked about some of these things, we're saying, oh, it's a medium concern. But actually, like, the chance of someone exploiting this are really low. And there's a whole load of factors as why that would be the case. One of which is that when you look it up against something like ExploitDB, Well, there's actually no public exploit entries associated with this. Like, no one's actually exploiting it. You could check KEV, the known exploits and vulnerabilities, to see is it being exploited in the wild, of which it wouldn't return anything associated with KEV. We can see it's actually, in this case, not listed in KEV. But also the information that comes back from that normal CVE report, which is say something like vulnerability exists in this version of a client, and it is or is not fixed. As I say, it's really short, like 1 or 2 lines. Compare that to the curl command I've run below, which is to curl the Kubernetes API, reference that same CVE ID, which I did above in the exploit checker, and suddenly you get all this additional supporting information, which you absolutely need as well, which is things like, okay, where's the raw issue, or sort of the issue associated with this on GitHub? So I need the link for that. I need to also see like the full context about how would someone compromise this, and more importantly, how can I fix it right now? And if I can't fix it, how can I mitigate it? And how can I observe it to understand, am I potentially compromised by this thing? And again, this is a fixed version, so it's great to run these two things in tandem. So yeah, this is again, yeah, sorry.
Yeah, sorry. I questioned about the previous one. It is, for example, this is a month in the middle vulnerability affecting C# clients. What is the most likely attack scenario that makes this a high risk in a production Kubernetes cluster?
So how does it become a critical in this case?
Yeah.
Or are you asking what would be an example?
And this exactly.
Yeah, so in the case of like a critical case, could be something like anything where someone can run essentially a payload, a pre-packaged script, and just do something very straightforward that would apply to multiple organizations that didn't require customization. Anything that can do scanning externally, see, okay, these are the systems that are running Kubernetes, and then run an arbitrary command the same way across each of those. That would certainly increase the risk of exploitability, because it means they don't have to manually adjust what they're doing in regards to reconnaissance, but also execution on how they would exploit that. So in this case, it still requires someone going into a directory, being able to make changes. So of course, that's does significantly reduce the severity associated with this vulnerability.
Yeah, got it. Thank you.
No worries at all. Again, I don't want to spend too long on each of these vulnerabilities. Essentially, there's another example where we're seeing to do with secret store, and again, it's addressed in a specific version. And you can, of course, use monitoring tools, or in this case, you can log the output to see for CSI if, again, you've configured it in the same way that potential vulnerability exists here. And again, this is just a perfect example of just using the exploit checker alongside the existing API for Kubernetes IO. So what I'm trying to show is the first thing is, okay, so there are many different things we need to stay ahead of when it comes to Kubernetes vulnerabilities, and it's pretty frustrating. The first thing is, you'll see a lot of the things I showed you there a while ago involved creating custom columns. So even just things like running workloads inside your environment. You could run kubectl get pods-a, and that will show you here are all the pods in all the namespaces. Or you can use -o wide, and I'll show you all the IPs associated. Or you can use -show -labels, and I'll show you all the labels. But finding more important things like what are the running or what are images associated with my running pods, and what are the containers with what are the service accounts, and what are the permissions. To get that kind of information, you need to start doing something like this, which is to say, create custom columns, extract metadata, associated with those pods. And that is really ugly. It requires a lot of customization, even just to do inventory of what are the things in running my environment on certain versions that are potentially vulnerable to attack. The other issue is things like tracking provenance and trust, especially if it comes to using something that we wouldn't vet as approved in our organization. So do we have an easy way to find out who signed that image? By default, the metadata that's exposed by the Kubernetes API server, most pods don't really provide that information. It's not very easy to see, okay, who signed it and find out what's the Git build and all this kind of stuff. So we can see the image, but really we don't go deeper than that with kubectl. So it's very hard to understand, okay, well, what are the dependencies associated with those images that are running inside our environment? We need to start then use vulnerability scanners. So we'll use something like a Trivia or a Gripe, and we'll go through that in a second. One of the things you can do to ensure that you're only using things you would trust is I use OPA Gatekeeper, and you can use it for a whole bunch of different use cases to address some of or mitigate some of these vulnerabilities, because Gatekeeper is like a normal version of OPA, but you work closely with the existing APIs inside Kubernetes. So it's running, you could have some custom resources running within Kubernetes, and basically you just specify what are the resources that you want to create these rules based on. So you create a constraint file or constraint YAML manifest. And in this case, you say, okay, I want it scope it or match it to pods, deployment, stateful sets, replica sets, daemon sets, jobs, and cron jobs. So it's a whole bunch of different things. And I've interacted with those different APIs, whether that be, again, the apps API or the batch API, to say, basically, we're scoping something here. So it is to allow specific repositories. And then I create a constraint template associated with the constraints. And what this is doing is saying, with that same target API, which is the admission controller for Gatekeeper, what I'm saying is, okay, I'm going to create a violation if a container is running an image that's not starting with docker.cloudsmith.io. Of course, you could do this for different registries. You could have it for Azure registry or GHCR for GitHub Container Registry, whatever it is. The point I'm trying to make here is, if your images are scanned and you've done all the provenance checks and you've done all that, great. But that will be in your registry. And then you pull your container images from a registry. And what you don't want is that a developer, a DevOps engineer in Kubernetes is just pulling like kind of sort of random images from random sources from the internet. And, they end up pulling something that's insecure and that hasn't been vetted and done the provenance checks and vulnerability checking and stuff like that in the registry level. So what you end up getting is something like this. Is when I use my tool, what I did is I use it to enforce the OPA Gatekeeper rules, which obviously are created in milliseconds. You can see here I created the constraint and the constraint template. The idea here is when I create those services, of course, those don't have an image associated with the actual service itself. But when the pods try doing the image pull, they'll say, well, sorry, that this is forbidden. OPA Gatekeeper will prevent you from doing that. So that's one of the controls you can do to stop with an admission webhook, to stop someone from actually pulling an untrusted image source. Then it's the issue of patching in production. As I mentioned a while ago, especially in Kubernetes, it's really hard to say, oh, we're going to upgrade our system, because there's like hundreds of different workloads, thousands, I should say, millions in some case workloads. And in that case, it's a production system. So you can't just simply upgrade. So oftentimes you're going to need to do temporary patching, making changes to files to prevent exploitation. So you're doing your best effort until such a time as you could ever upgrade. So even if there's no fix available, or there are, we'll see in a second how many fixes are available, it's not so easy to simply just upgrade right now from a compromised version. So I actually can't remember why I put this in here, but main thing, it was like, when it comes to vulnerability detection, as we say, not everyone can upgrade. So you want to check, well, can I prioritize those vulnerabilities? As I say, there's different severities, from critical, the ones you should be really concerned about, to the ones that are low, that aren't really that important, or really trivial for someone to actually try to exploit. So you want to check, is it critical? Then the other thing is, a lot of the vulnerabilities will say it's something related to exfiltration to a C2 server. So if you can easily inventory, does it expose to the internet? Well, even if the CV, the risks, or the severity is like high or critical, in reality, it might actually be next to zero risk to your organization, because you're in an air-gapped environment that doesn't talk to the internet. So being able to ask these simple questions of like, am I potentially running the environment that matches what they need to exploit that vulnerability? And then the other thing is it reachable? And if it's not, if it is reachable, then of course we want to fix it. We want to do everything we can to prevent them from exploiting it. But if they can't reach the environment in order to exploit it, then of course they can't retrieve the information externally to that command and control server. So I know there's a lot here. I don't want to spend the whole time just talking about CVSS and EPSS, but I know these scores do exist. And when you do a check for any CVE on a public facing address, you're going to see things like, what is the severity, what is the score, the CVSS, the criticality of the score of that vulnerability. And then you'll also see something as well. This will be the EPSS. It's a likelihood of exploitability for that, like of that thing being exploited. The difference between these scores is, generally speaking, CVSS is like added at one moment in time, and it could be a 10. And then over time, we realize it's actually not as concerning as it was. whereas the EPSS scores are adjusted every day. It's a machine learning model. So that's certainly a supporting system that we need to complement it. And I don't want to go through this forever, but basically CVSS existed forever, and it's a static thing that barely ever gets adjusted, whereas EPSS is a rolling based thing that's getting updated regularly. It's a probability score. So like on a probability of like up to 100%, what is the chance of this thing actually being exploited in their environment? Yeah, again, these are kind of not very interesting, but it's about like, how are these scores provided? So as I say, base scoring, it looks like exploitability, intrinsic characteristics. It's basically security researchers who investigate when that vulnerability is disclosed, and they say, we looked at all these different conditions and I've given it a score. And that's the CVSS score. But it doesn't address the issues of like, does that actually matter in my environment? And that's why you need something else to basically see, like, for instance, am I public facing on the internet? And therefore, can this environment be compromised externally from the internet? Something on those lines. So it doesn't take that into consideration. It's very much theoretical because it doesn't know anything about your environment. It's just saying, wow, if someone were to make the change here, they could absolutely do these things. So that's something you want to factor in, and that's why CVS scores exist the way it does. Whereas EPSS can address to an extent, and it'll say, well, it's constantly being updated. So with that additional source, you could say, what is the likelihood of this thing being exploited in our environment? On its own, it's useful if there's no CVSS score created. So sometimes CVEs are created, but no CVSS score is disclosed. Rarely, but sometimes that happens. In the case where no one can agree on a score, then at least EPSS exists as a sort of a last resort to tell you, should I be concerned, until such a time as the CVSS score exists. But no CVE, there will be no EPSS or CVSS, so they don't exist on their own without CVE IDs. Again, I won't spend too long prioritizing the score system, but the idea being here is like, if we can look at things like known exploits, are people actually exploiting these things in the wild? We look at the base scores to see, okay, you know, was this critical or not according to CVSS? And then being able to complement it with EPSS to see what is the likelihood of this thing being exploited. Well, we get a much better picture of like, what are the actual, you might start off with like 922 known exploited vulnerabilities, but reality is there's only like, you know, 25 or something like that, or 200 that we actually need to focus on. So we want to do something on this line where we're basically scanning with our Triffy or gripe. We want to see what is the score assigned to it from a CVSS. We want to look at the likelihood of that thing being exploited. And if we can do some kind of priority-based calculation of like, is this priority? These vulnerabilities say they all are to do with public-facing output, but we're not touching the internet. That, just as one example, that would be used where we can say we might have to have acceptable risk. Because as I say, not all CVs have a fix. So in some case where there's no fix availability, there's nothing we can do. If there is a fix availability, of course, you can file a ticket, Jira, whatever, to another team in security, and they can, whatever, patch it if that's the case, or DevOps engineer can patch it. But if there's no fix availability, there's nothing anyone can do. So the idea of filing tickets based on, we found a critical vulnerability, sometimes is really frustrating if there's actually nothing you can do about it. Certainly prioritize critical by default is the right way to go, but it's important to pull in different source data like exploitability and known exploits to make better, more informed decisions about whether or not we take action. And again, the idea here is you might be flooded with 100,000, 117,000 vulnerabilities, but when you start looking down at things like, is there a fix availability? You know, has there been exploitation in the wild from like ExploitDB, you know, and then look at, oh, well, is it in use? Because that's the other thing is like, we might have all these container images that have known vulnerabilities, but actually what are running currently in our Kubernetes cluster? The more context, the more things we look at, we want to focus on the 114 things that are in use inside our Kubernetes. We don't want to focus on things to do with older distributions of Kubernetes, older versions, older pod images that are never running inside our environment. Those things don't matter. So we want to focus on the things that we can take action on. Again, this comes down to runtime forensics. There's a whole different suite of tools. You know, the two that make most sense are like Falco and Tetragon, two open source solutions. Falco being a CNCF graduate project, and being able to say, well, these tools are great. You know, they could help us for monitoring. Am I currently being compromised by said, is that vulnerability being exploited? And yes, there are rules where they will say, here's your rule. It's for packet socket created within a container, and they'll say is tied to a CVE ID. And this is all really good. This is great because they're showing here's a rule that this thing will get triggered if it's being exploited. However, the issue now is that do you constantly have rules created? They're updated, fresh for these new CVEs, and it becomes a little bit more frustrating over and over again to say, I'm not keeping up with it, and it's another tool set I need to maintain. So oftentimes you need to go back to the basics and say, well, what can I do to stay ahead of these CVEs? So we talked about scanners. Scanners get updated at least, the database associated with those. So you can say, okay, here are all the latest CVEs. We said earlier that there's a curl API, but you still want to do the right thing. So our approach is we use OPA throughout the board. So we showed OPA gatekeeper as a Y earlier at runtime to say I don't or do trust images being pulled from, or being used from specific sources. That's something you could do. Again, if a vulnerability is associated with privileges, then you could, of course, say, well, don't let that pod in that given network namespace run with certain privileges. That is something you could genuinely approach with Gatekeeper. But we use OPA on the registry level. So before it ever comes into Kubernetes, the idea is you're going to run so many different pods, so many different deployments that are going to be across your Kubernetes cluster. And of course, these CVEs are constantly being updated. So the idea is the registry that you're actually pulling them from, you want to scope rules to specific registries to be able to say, whether it be staging, production, you want to say, okay, well, I'm going to create a pod, any image, any source dependency, whether it be a Python package or a Ruby gem package, whatever it is, that's eventually going to end up in a Docker file or a Helm chart. These are all packages. These are artifacts that we're going to end up consuming within Kubernetes. So you want to scope to in a certain environment, and you want to say, well, I'm not interested in those two CVE IDs we mentioned earlier. They're not applicable to environment. They're just noise. We got these high vulnerabilities, but there's no fix available. So we're going to exclude those. You may also want to say, well, I'm also only concerned with the CVSS scores that are above 7, which might make a lot of sense because that filters out basically your low or low medium ones. You may want to only trigger on cases where the CVE was disclosed over 30 days ago. So, the newer ones that people are still figuring out where the CVSS scores aren't assigned, stuff like that, maybe we want to exclude those because they're not being actively exploited right now. The beauty of this approach, whatever it is that you filter into this rule, and this is just a generic example, is that you can fill in the message context. So whatever it is that you are building a policy on the registry level, you may want to have an output that basically says, well, this package had a CVSS score of 7.5. Reality is we only want to let things that are over 7. And there's a fix available on this one, so there's something we can do about it. And I don't know, some other context you can strip and put that into the output. And that really helps with triaging. That way, when a ticket goes to someone who needs to take action, they're like, wow, that's all the supporting information. I don't need to go investigate it. That's in the output. And more importantly, that there is a fix available. So that's something you do on the registry level. Say, I only want to prioritize the things that can be fixed. So you can use OPA, like I say, here's the example we use with the Cloudsmith package API. And that's for the registry level. And we showed OPA a while ago to control or approve, like its admission at runtime within the cluster itself about what you do and don't run. Again, it's a really tough thing. There's no straightforward answer about addressing CVEs. There's all sorts of solutions you can come up with, like using minimal images to have less CVEs, or again, keeping systems up to date. If you have the freedom to do that, then of course you are always able to reduce the number of vulnerabilities in your environment. We're aware that not everyone can do that. Some people are many, many versions behind. And in those scenarios, they're going to have many CVEs that are going to exist in the environment, but not all of them are fixable. So they can't prioritize fixes for things that can't be fixed. So they need to prioritize instead mitigation steps. But also in regards to images that we're pulling with dependencies, and there's just so many layers of abstraction when it comes to Kubernetes. You want to, first of all, pull those artifacts from trusted sources. I'm not telling you that you have to use Cloudsmith. I'm saying whether you use GHCR or Azure's container registry, or if you're using Sonatype Nexus, whatever it is, specify what is the trusted source. So at least you're only pulling the things from the trusted source that developers or DevOps aren't actually pulling them from untrusted source that they don't know contain vulnerabilities. And that's just the workloads. Again, I want to stress that we don't want to be telling people all the controls are done at the production level within Kubernetes. You can, but so of course it's encouraged to be doing the scanning in production. But if you can mitigate it any bit by doing scanning earlier on the process and doing controls earlier on via OPA to control what does or doesn't end up in your cluster, that helps incredibly in this case. So again, even with OPA, it's only as useful as the policies you enforce. So whether you're doing an OPA policy that says, oh, I'm going to block things from executing, containers from starting that have certain levels of privileges, well, you don't want to make a really broad OPA policy that ends up killing a load of pods or doing something that's not supposed to happen. You want it to only scope to the vulnerability. And as I say, new CVEs are always being disclosed, so you can't just keep making a huge list of OPA policies for individual patches, because even in that scenario, whether it be Kyvern or OPA, that becomes a sprawl issue that you have to manage as well. So you need to think responsibly about what we're doing. And that always comes back to the step of doing proper inventory of environment. That's why those issue links on GitHub are so useful, that they provide that supporting information about what is the next best practice. And as I say earlier, exclusions for the things you can't fix, that you can mitigate to some extent, or you can monitor, but you can't actually patch. Then you need to eventually exclude those if you've got mitigation steps in place to avoid that noise of we have all these vulnerabilities, when in reality, most of them aren't applicable to our environment. Yeah, again, what we end up doing is creating something like this where we say, here are all our CVEs. They have different scores from severities from low to critical. What I try to do on a simple level is say, okay, if you have a high CVSS score but a relatively low EPSS score, what are the actions? How should I interpret this information? And eventually, if there's no fix availability, then we say, well, let's just exclude it from further, at least monitor the situation. But if there is a fix, always prioritize fix. If you can, again, as I say, not all environments can do that on the fly, especially in Kubernetes. So you may need to do further triaging. And as I say, in this case, in the case of critical vulnerability that are above a certain threshold, also on exploitability, you also need to look at internal use maybe, or if you're air gapped, you can get around it. But if it's like a production system where you're talking to the internet, for sure, you can't just allow critical vulnerabilities to exist with high risk of exploitability. That's where you start creating this gap about what we do or don't prioritize. That's what we try to look at within our organization, is if they're in that low end, we can monitor them, but we're just not going to prioritize those low exploitability risk, again, with low CVSS scores. But if they're high CVSS score but high risk of exploitability, you should be either looking to fix it or at least block, which is to mitigate the problem. I don't want to go through all these. This is basically examples of things that have high CVSS scores but low EPSS. I think you asked for an example earlier, which is basically some of them require local preconditions. You need to specify a certain path, and you need to make some fine-tuned examples in an XML file. These are all these would never work in mass exploitation. For something to be high EPSS as well, high risk of exploitability needs to be something that you don't need to craft anything custom. You could just run something arbitrary, run against all these different environments. Again, mass exploitation examples. Also, why EPSS is useful is that sometimes CVEs get created and it takes ages before the CVSS score is assigned through NVD, because they're dealing with so many vulnerabilities themselves that need to be registered. So as long as the CVE ID exists, eventually we'll have EPSS data to say, again, it's updated every day. So that then we can say, okay, what is the potential extreme risk associated with exploitation here? You can scan these. I can put these back up in a while, but what I'd love to do is just show how this works inside the tool I was working on earlier. So we had a few vulnerabilities. So one of them is, I want to go to, I'll move that, and I'm just going to go to the terminal. And again, stop me if anyone can't see this, but what we want to do is, let's say, I can do my exploit check. I'm just going to put this up here, and we're going to say exploit check, and I'll say query the CVSS score, which is just that CVE ID. you can see in this case where this isn't a particularly high CVE either. It's where you can see it's got a CVEs score of 4.1, which is in that medium category. But the actual exploitability is like less than a percentage. It's very, very low risk of exploitation in our environment. As I said earlier, is that if I was fetching this information from NVD, then you'll get this like short description that says, well, you need to do this, like here's the vulnerability, and if the user can view API server logs under a score, yeah, that's how they'll be able to exploit it. But compare that to when we found our first CVE, which was this one. When I grab this command and we go back into our terminal, it's much better the outcome I get from Kubernetes themselves. They give me a deep dive into what's going on, and of course the associated ID from cve.org, but also the issue link. And the issue link is probably your best friend in this scenario. It's so that you can go in here, you can just open it up at the top, and then you can say, okay, what is the issue? How does it get mitigated? If this thing's being updated in real time, you know, the discussion link will exist here. So again, that's the best place to get your information about and as we said, it's open, so it is unfixed. It's still outstanding within the Kubernetes project itself. I mentioned at the beginning of the session that there was a way for us to easily look at what are fixed versus open. So like most of them should be in this category of fixed. So as I say, if we go into here and we cleaned up, we would see that there's just a long list of fixed vulnerabilities in the system. But when I actually looked up recently for the unfixed ones, which was basically that same command, but we changed it to open, it's really just one example. Look, there's just one open vulnerability. So that's the one we just said there a second ago. And the second example that I said also doesn't have a fix available is the unknown one. So it's not like there's a huge list of unfixed vulnerabilities inside the Kubernetes ecosystem. Actually, the reality is most of them are in that fix example, you know, where you can just go through the list of here are all the fixed ones. So I showed a while ago how you can filter for any given ID, which is basically run that curl command where you specify the ID here. So if you wanted to find out the information on any given one, you could just put in the ID here, and then that curl request is going to work for you. So it's definitely a really good tool for getting full context about things like when was it published, who filed this, you know, what are the solutions to fix this? And again, hopefully none of this is stale information. It's regularly updated. As I said a while ago, there was the exploit checker tool that I was working on. So one of the use cases for this is Kubernetes is kind of a mess. As I said earlier, you need to do custom columns to understand what are the images running associated with your pods, so on. So you could run this exploit checker to check the images in a namespace, right? Something like that, and just say something like -a. Oh yeah, did I spell images correct? Images namespace. Oh yeah, I didn't spell namespace correctly. A namespace -a. And what this will do is that essentially what we were showing earlier, where you list the images associated with these running pods. But what if I wanted to scan all of the images in a given network namespace or with certain context in their image name? Well, that was the point of the exploit checker originally. So it was a way for us to say, well, let's say I want to scan the namespace default. So this will show that in the namespace default, there is only one image inside here. So if I wanted to scan that image, you could just scan the image directly by doing something like this, which is to say scan image and then put the image ID. And if you wanted, you could scan for severity. So this is your low, let's say low and critical. I won't even say medium. No, I'll say high as well. So now I'm going to exclude medium. So now notice there's no medium scans are going to show in here. So I have a lot of low, a lot of these things for that given image. And this is Trivy behind the scenes that's working here. But you can see here the low ones. These are all the dependencies running inside that container. But we said we want to prioritize the things that are fixable. So notice how some things like you might have a CVE ID for a dependency in a container that is considered high. But notice how a fix would tell you, well, if it was in this version, it was a problem, well, you just upgrade it to this version. But in the case of this CVE ID, there is no fix. So there's no fix version for that. So if I were to say, for instance, say exploit check, query that same CVE ID, and additionally, I want also see from osv.dev the package info. Well, I could use it in that case to say, well, although it's got a really high, it's got a high 8.8 CVSS score, the reality is there's like a 0.02% chance of this thing actually being exploited in our environment. So although what sometimes seem really high based on CVSS, which that score hasn't been updated since it was originally filed, the scores for exploitability can be much lower. And if it can't be fixed in our environment, then you want to prioritize against different information. So I said earlier that you can use this tool for prioritizing it based on severity, but you could also use a different scanner. So I could tie in something like Gripe. The reason why I'd use Gripe as an additional scanner is you might want to compare your scores across your different vulnerability scanner, but you also want to look into things like KEV. So there are, say, one image here, which is the docker.cloudsmith.io is where I'm hosting it. So this is in my Cloudsmith registry. You can see my organization, and here's the image, AI image latest. There's a whole bunch of different dependencies. They're like Debian packages and Python packages and all this kind of stuff. But a lot of them have, first of all, really, really low risk, which is the associated with these EPSS scores. But only one of them is actually ever known to be in a known exploited vulnerability. So that's the KEV index. So it's important to really compare CVSS, those severity groups, with things like risk of exploitability to understand what's the actual risk associated with this thing. And for the things that can't be fixed, like we mentioned earlier, what was the example that couldn't be fixed? It was in Langflow, but it was one vulnerability in Langflow. The one that we should focus on, which is the CVE 2025, the 32848, which is, well, it should be associated with this GHSA. The point is the one that can be fixed is the one that's in a known exploit, things that are being exploited in the wild. But the thing that isn't being exploited, that other vulnerability, which we saw here, is not showing in any public entries. It's not in a KEV index. That's also got a pretty low chance of ever being exploited. So it's something we should deprioritize as far as risk goes. I could talk about this system all day, but the last thing I would just say as far as using the exploit checker, if it's something you're interested in using, is that if you wanted to scan, for instance, an image, say you could check for images. Actually, I can't remember how I used this again. If you wanted to say images, namespace, and we said, let's say kube system, this should be how it's used. If you want to scan, that will list all the images that are in that namespace. But if I was to say Kubernetes namespace, so Kubernetes namespace and kube system, what that will do is it'll scan all of the pods in that given network namespace. So in a scenario where we have a really big environment, like we mentioned earlier, let's say -A, and we want to look at all our containers, I might want to scan all of these kube system things at the same time. And traditionally, scanners weren't built with that Kubernetes context. So having another layer, an abstraction layer that's basically taking the metadata that we showed earlier in these custom columns and piping that into our request, it's a much cleaner way to do something like this, to say basically use exploit check, scan everything in the namespace kube system. And if you can easily filter down for things like where there's KEV information, like we saw earlier with the Gripe scanner, then we're in a really good situation where we can say, these are the things we should focus on and filter out all the others. I could do it where I could say, hopefully this works here, where I say severity critical. Yeah, and I'm only getting those critical examples. And if I could go further and check for fix availability, then filter out the things that can't be fixed. So I hope this session was interesting. I didn't want to go over time and I want to leave time for questions. So any questions at all, I'm more than happy to answer.
Of course, so interesting, so exciting. We have a question right now from Dorian. The question is, would you not miss container which delete metadata of package manager if you scanned on entry? So it is the question right now. Let me show the question in the chat.
Yeah, would you? Oh, yeah, see that. Would you not miss the containers which delete metadata of the package manager. Would you not miss containers? So you shouldn't miss containers if they delete metadata associated with package manager. I'm just curious, what's the concern here? So if an adversary wanted to go in to find the metadata associated with container and remove the source registry is where they pulled it from, would we not be able to see where we're pulling images from? Like generally speaking, with the OPA control, I think that's what you're referencing. We said earlier, only allow these things from this approved registry, if that's the question. Hopefully I'm answering that correctly, but yeah, like if you scan on entry, we can scan all containers in the cluster basically.
Probably I want to motivate Dorian. If you have more questions, you can go directly to Nigel from LinkedIn, something like that, and probably you can make this question because it is probably my next question. Nigel, your insights on prioritizing CVEs were available. Thank you so much. Your session was amazing. Of course, I think so. We can have all hours and hours talking about that. I understand. So, what technology behind OpSynth about? You mentioned a Trivi. What other technology behind OpSynth you are using, for example, in order to detect this kind of things? So what is probably the hard technologies, the backbone technology that you can recommend to people involved in order to understand better your product?
Yeah, no, absolutely. So the main thing I wanted to just get across, and I could put it in do I send it in the private chat? I can send it in private chat if you can send it to public chat.
Okay.
Basically, I put together a GitHub repo. It's badly documented, apologies. But basically, it's just a bash script. And what I'm trying to get at is whether you want to use Trivi or Gripe as your choice of scanner, both will be configured in a way that what we're trying to say is, look, Kubernetes has a whole bunch of different metadata and cool information that you would need to extract normally into custom columns. What we want to say is, look, all we want to do is filter down the noise, all this different signals, all this different information, so you can get in a clear picture, what is the thing I need to prioritize? So what I'm doing essentially curling these APIs. So things like, that's the underlying technology. So curl is basically saying KEV, NVD, ExploitDB, Scientia, whatever these different data sources are, can I put it into, or osv.dev, putting all this information to a single view where someone can say, okay, these are the things that are running in my environment. These are the dependencies. These are the ones that have critical vulnerabilities. These are the ones that are fix available. These are the ones that have risk of exploitability, and of course, which are known exploits or being exploited in the wild. If we can filter down the noise with different signals, eventually you can end up with 5 things where you say, these are the ones that we know are critical, where there is a fix available, and they're currently being exploited, and you should be really concerned about it, as opposed to what we showed earlier, which was hundreds of vulnerabilities in just one single container, which is, of course, a reality for a lot of workloads.
Yeah, nice. Other question is, how would you prioritize CVEs differently now that you have seen how EPSS and KEV complement CVSS?
Yeah, so there's not a simple answer. So we showed earlier where one of them, I created an interpretation table where I say, if you've got really, really low EPSS, but you've got a really high CVSS, you start to disregard sometimes the CVSS scores as they're kind of archaic. They've been around for a while and they're not accurate, and that happens sometimes. So I would use in that way. The best solution I've seen is when we used the Gripe scanner earlier, what they did is they took the CVSS score and the severity, they took the EPSS score, and they created this another column which basically said risk. And they said, how risky is this thing? And then they created as a table downwards of from highest to lowest score. And by assigning KEV beside it, we went, wow, I have hundreds of dependencies, but only one is being exploited that I need to fix. And by the way, there's a fix available. So they created it the most humanly readable solution from that information.
Yeah. Thank you so much. So we had a great discussion today. To follow up, what is the best place for our community to connect with you, Nigel, your community website, social media, or perhaps a dedicated project repository?
Yeah, absolutely. I put the piece up there on GitHub. So of course you can use the exploit checker from the information provided there. I love feedback. I love communicating and working with people. I'd say the best way to reach out to me right now, while we don't have a dedicated community line at Cloudsmith, is just reach out to me on LinkedIn. You could also reach out to me on Kubernetes IO, the Slack channel. I'm also pretty active there too. So yeah, feel free to contact me directly. I look forward to those kind of comments.
Yeah, Thank you so much. I don't know anything else to share with us, Nigel, or that's it from your side. I don't know.
No, I was conscious of time, but I think we demonstrated everything in enough time. So yeah, looking forward to the next session.
Yeah, appreciate. Thank you so much, Nigel, and all of you, community. Thank you so much for watching us. Please share this topic in your social medias. Comment Nigel, comment the company, comment the products. Why not go to the repository right now and Douglas Clausmith / exploit check. So you can try, you can explode, you can explode your cluster, your local cluster. Please take care about your production cluster and enjoy this technology. Thank you so much, Nigel and community, and see you soon in the next Cloud Native Session Live. Take care.
Thank you so much. Have a good one.